In this video, we'll try a much simpler DSA problem. We will convert a binary number. Given a binary number, we will convert it to its decimal format. So, given this input 101, we need to arrive it to its decimal equivalent, which is 5. Okay. So, the logic of conversion of any binary code to a decimal equivalent is uh, you apply the individual digit uh, with respect to its power value. So at the first iteration, what you need to do, traversing from left to right, you need to do 1 into 2 raised to 2 at the first level. So first, at the first thing, it will be 1 into 2 raised to 2, so, like this, right? Then at the second level, at the second iteration, this should be, now that you have already processed 1, now it should be 0 into 2 raised to 1. Third will be 1 into 2 raised to 0. Okay. So here, as you see, the 2 is constant because binary has 2 only as base. This is the value that we are traversing from left to right, and this is the uh, counter value, you can say, that gets reduced as in when we move from left to right. So keeping this in place, we move forward and we write our code. Uh, we can have a counter variable that is initialized to input strlen -1. Now this input str is basically str of input, and in our case the input will be 101. Let me call this as sample input, and let me call this as sample input. Okay. So this sample input we have as 101. We have converted it to string, and then we now the length of this thing is 3. We want 2, 1 and 0 only because of the indices. At string level, the indices begins from 0. That's why we did n minus 1. Even for loop would work for I in range of, for I in input str. Let's call this as digit, right? Now we just want to adhere to this formula, right? So here the formula will begin as int of digit into 2 into the power value. So it begins with the counter value as 2. At every iteration we decrement the counter by 1, and we store the sum value, or you can call this as decimal value, that is initialized with 0. And every time we do this, we need to do this. This is actually the sum of all this, plus and plus. Now when I go ahead and print this, this would give me the decimal equivalent. A similar approach that we could do, just for the thought, I thought that I would share this also with you. If we didn't wanted to use the counter variable altogether, what we could also do, we could do for digit input str, right? And this would be in the reverse order, reverse input str, and this will be for idx comma digit in enumerate, right? We are traversing from right to left. So from right to left, it is expected that the end value to have the exponential power sum as 0, and that is what we will get in the index, right? So you can check this also. If I do this I am getting 012, right? So again the same thing, it's just that the counter variable is not needed altogether. We can directly put idx here, and this whole thing can get removed. Let's call this as decimal value 2, right? And this becomes decimal value 2, and finally we can print this decimal value 2. Yep. Thank you.